Welcome everybody. Today's topic, as Daniela stated, is going to be Modapts, Simplified Time Study. We talked a little bit about what PMC does in the different areas that they concentrate in. The bottom line for PMC is really to help the customer maximize the ROI and increase the profits. One of the greatest ways of doing this is by utilizing Modapts. I'll give you a quick outline of what we're going to do here today. We're going to take about 15-20 minutes to do this presentation. We're going to talk about the definition of what predetermined time studies are. We'll talk about some history on predetermined time studies. Then we'll go into the Modapts and the advantages thereof, where the Modapts applications are, and a brief introduction to some of the elements of Modapts. Then we'll do a quick summary. Predetermined motion time system. The predetermined motion time system is frequently used to set labor rates in a labor-oriented industry by quantifying the amount of time required to perform specific tasks. So that being said, it can really be utilized in nearly any industry, from automotive to hospitals to banking to office work. Anywhere where this is task-oriented or tasks are assigned, predetermined motion time studies can help. One of the first motion time studies was MTM, called Method Time Measurement. It was released in 1948, and now it exists in several different variations. There's MTM1, which is optimal for short processes and only really small hand motions. There's MTM2, which is an advancement of MTM1, MTM UAS, MEK, MTMB, which is used for longer and less repetitive tasks. There's also the obsolete ones that were around, MTM, MTM3, 4M, MTM2 standard. These predetermined motion studies is another way to describe time standards. MOST is the second one that came out. It's another popular motion time study. It's called MOST, Maynard Operation Sequence Technique. It was first released in 1972. And then it was acquired by Accenture in 2007. MOST is utilized a lot. Most variations are basic MOST. It's more suitable for processes that average around 1 to 5 minutes. So a basic task. There's mini MOST, which is optimal for really short processes, less than a minute, and only small hand motions. There's no real body movement in it. And maxi MOST, which is good for real long and less repetitive time. Now, if you notice between the MOST and the MTM, they're really based on the same concepts. The problem with MOST and MTM is there's so many concepts, it's difficult to decide which one is the best one to apply. Then you come to Modapts. Modapts definition is a modular arrangement of predetermined time standards. It's used today in automotive, sewing, healthcare industries, as I stated before, office work, banking, anything that is task-oriented. It was introduced in 1966 by Chris Heide. It was originally learned by MTM1 and MTM2 methods in the early 50s. However, they sought out to find a simpler technique. MTM1 and MTM2 are not difficult per se, but they're very, very detailed to the point where it's difficult to apply. But unlike MTM and MOST, Modapts uses a mod. Mods as a basic unit of measurement. So basically 1 mod equals 0.129 seconds, 1/8 of a second roughly. Basic MOST and Modapts uses a coding technique that consists of a letter and an integer. The letter represents the basic movement. So M would be move. G would be get. We'll go over some more of this later on in the presentation. The integer numbers each represent mods that can easily be added to determine the coded task. So you might have 2 mods, you might have 3 mods. All of the mods, though, are predetermined. The movement of the human body has already been studied and it's been timed. We know how long it takes to move a finger, to move a hand, to move an arm, to move a waist, to take a step, to bend, to kneel, to sit. All these times have been studied, and they're all predetermined. Some of the advantages of most is the accuracy of the standards that are derived from Modapts. It's comparable to other acceptable time studies techniques such as MTM and MOST. So as I said before, MTM and MOST are good studies. Modapts is just easier to apply. It's possible for the average supervisor to learn Modapts and establish the standards. We can generally teach people to do Modapts in under a week and certify them, and they can go out and right away hit the floor and begin to apply what they've learned. The average employee is able to understand Modapts and how the standards are calculated. And by understanding what's really going on, most employees embrace this and actually like it. They welcome it. It's good for morale. It helps the employees to understand the management goal. It helps management to really set clear and obtainable goals and expectations. It's not complex. It's easy to learn. As I said about the integer values, 1/8 of a second basically. It's method sensitive. That being said, that if part of what you're doing is typing, well, then the method is utilized would be the typing. It encourages method improvements. So if we look at a process and we're studying a process and we notice non-valued time being added to the process or to the task, we're able to point that out and say we can save X amount of time by removing this non-value added time. It highlights ergonomic concerns, which is a big concern, especially in factories. Computer simulation, adaptable. It's inexpensive. There's no royalty fees to pay anybody. Anybody can do it anytime they want. You should know how to do it before you do, though. It's more consistent operational analysis. Possibility of controversy is almost eliminated. There's always somebody who's going to argue the point, but they have a very difficult time proving something that's been around since the 50s, and it's embraced by nearly every labor union. It's always been said that stopwatch is the easiest and best way to go. But the problem with stopwatch is, first of all, it can be intimidating. If you stand and you look at one of your people doing a task with a stopwatch on them, they might feel like they need to rush. They might feel like they need to cut corners. It's an extremely intimidating way to go. Modapts doesn't require a stopwatch. Stopwatch is performance rating required. That being said, one person might be able to do a job faster than another. Even if the exact same motions, they're just able to move the motions quicker. In Modapts, there's no performance rating. The motion is already determined how long it takes. Stopwatch is not ergonomically sensitive. You are not going to be able to point out non-value added time. Modapts, you can. Stopwatch is also not method sensitive. So what is done is recorded. Modapts is method sensitive. So how it's done is actually recorded, not what is done. Modapts applications, generally applied to repetitive tasks with short, medium-length time cycles. So that could be anywhere from a task might take 1 minute, it might take an hour. But generally it's not going to be an 8, 12, 15-hour task. You can calculate time it would take to complete given a job when working at a standard pace. That's important to recognize, working at a standard pace. A standard pace is defined as a pace that can be kept over an 8-hour period. That's a standard pace. It works great for line balancing when factories. That can also be applied to janitorial services. It can also be applied to banking and to typing. It applies job costing pretty easily. So if you have an end product coming off the line, you really want to know how much that product costs you. Short of the material and the machining, the expense really comes in with labor. So how much time did it take to create one unit? That time equates to a value. With Modapts, you can get that value. It's also a basic building block for establishing standard work instructions. Every task should have an SWI assigned to it. And doing Modapts, you automatically end up with an SWI when Modapts is completed, when it's done correctly. Some of the steps involved in conducting a study You document the elements involved in completing the task. Perform the Modapts analysis on each of the elements. You compute the mod values for each element. You sum the mod values up to determine the total mods or time per task. Then you convert the total mod value to seconds or minutes or hours, however you prefer. Modapts is a system which relates standard time values to movements of the human body when work is performed. In Modapts, basic units of work are expressed as modules, as we stated earlier. One mod, 0.129 seconds, or 0.00215 of a minute. Every activity is identified by a two-part code. The first part is an alphabetical component, which indicates the type of activity. The second part is a number, which represents time to complete the activity. So the element will determine the activity, which will determine the letter. The actual movement itself determines the mod. If you take a look here, you can see the basic movements. You have 1 finger, 2 is hand, 3 is arm, forearm, 4 is full arm, 5 is shoulder movement, and 7 is trunk, the trunk of the body. And then that breaks down into several subcategories, such as eyes for seeing, finger closing for grabbing, W for walking. It goes on and on. This is all part of what we would be able to teach within a course. Here's a good Modapts example. This is a basic activity of getting something. So if I want to reach over and get something, notice there's a G for get. Well, 3, if we go back and take a look at our example, 3 is my arm. I'm going to move my forearm to go get what I have to get. So G equals get, 3 equals mods. So 3 times 0.129 equals 0.387 seconds. It took me 0.387 seconds to move my forearm to go get something. The element classes you got, there's movement, there's terminal, and there's auxiliary. Movement is done by finger, hand, arm, shoulder, and trunk. It's required to position a part of the arm to perform the terminal activities. Rapid forward and backward or circular. The terminal activity is done at the end of the movement, such as getting something or putting something down. And then there's auxiliary activities. These are activities that are not performed with the fingers or the hand, arm, shoulder, or trunk system, such as walking, seeing, inspecting, even thinking and deciding. Movement classes refers to the movements through space, done by the finger, hand, arm, shoulder, and trunk, as I stated before. The movement class and activity is always followed by a terminal class or activity. So move to get or move to put. I have to move something to get something. I have to move something to put something. So every move gets a get. Every move gets a put. Movement classes with the finger is 1 mod. With the hand, which is M2, is 2 mods. With the forearm is 3 mods. The whole arm is 4 mods. The extended arm is 5 mods. And then your trunk is 7 mods. Now, how do I determine if I'm only using finger, hand, forearm, whole arm? It's really by the distance. How far am I moving? Am I moving 1 inch? It's finger. 2 inches? It's hand. 6 inches is forearm. The whole arm is 12 inches. And it moves on from there. Albeit these numbers are somewhat estimated. However, the exact amount isn't going to make a lot of difference, because between the M4 and the M5, the difference is less than a second. It's 1/8 of a second. So if you choose M4 rather than choose an M5, your time is only off 1/8 of a second. Movement class examples. I'm one of moving the fingers, like depressing a key on a calculator, maybe squeezing a trigger on a drill, turning down a bolt. Moving your hand might be turning a doorknob, maybe picking up and turning over an object. Anytime you do a walk, after you do a walk, you also have a hand movement. That's an M2. That's a given statement. M3 is forearm, so your wrist must move. You can move with a pencil. Maybe you're moving dividers around. Maybe you're picking up a telephone. M4 is a full arm move. Therefore, your elbow must be displaced. And it's common for picking up larger articles. It can also be moved with or without body assistance, which may require a trunk movement. M5 is the full arm move. Thereby, your shoulder must be displaced. It's not real common in office work. You won't often see that. However, you'll probably see it in the assembly plants, or you'll see it on manufacturing floors, or you might see it in janitorial services. Also, if you're doing a lot of M5s, you're going to see some poorly laid out workplaces. If you're always using your forearm, you're going to wear out very quickly. Or full arm, I'm sorry. You're going to wear out very quickly. That's reaching up over your head, maybe reaching far away to always grab something. The idea of Modapts is really to optimize the time. The best way to optimize the time is to put the common items for the task within a reachable distance. Another movement class is M7, and that's when you're moving your whole body. You're moving your trunk move. If you're moving an M7, M2 following a walk rule is waived. So your feet may be repositioned, but they don't cross. It's uncommon and awkward movement. M2 following a walk rule is waived when this happens. Terminal classes are activities that are done at the end of the movement and are in close proximity to the things being worked on. This class includes two types. As I stated before, there's a get and there's a put. So every movement, you're moving for a reason. Either you're moving to get something or you're moving to put something. So that's where you get your gets. It might be a G0, a G1, a G3, or a P0, a P2, or a P5. Those are the only options. A G0 is a contact get, so it's basically just touching. Maybe I'm going to slide a coin across the counter, or maybe I'm just pushing a button, or setting my hand on a piece of paper. A G1 is a simple grasp. That's just to get an object. So it's basically anything that you can just snatch up without any current real thought to it. If it's your coffee cup, maybe you just grab it. The phone, you just grab it. So this wouldn't include little items like a safety pin or a washer or a paper clip. Would not include those items. G3 now, those are for the more complex pickups. If I have to pick up a safety pin, or if I have to pick up a washer or a paper clip, I actually have to stop and put a little bit of thought into grabbing it. I can't just reach my hand over and close my hand and snatch it up. I actually have to close my fingers and take a look at where I'm grabbing it and grab it properly. So that requires a G3 grab. So the rule is if it fails the snatch test, it's a G3. If you can't slide it and it fails the snatch test, it's a G3. Then you go back to the next step. After you get something, well, you have to put it somewhere. So you have puts. A PO is a simple put, no specific requirements, objects placed in a general location. It's a very low conscious activity. So maybe I'm tossing a part into a container, or maybe I'm throwing a piece of paper away. Maybe I'm pushing a cup into the garbage. Something very simple. Then you get a P2. It's an item that require a little bit of thought. You have to put it into a specific location. You put with a single feedback from one or more senses. So the object is placed in a defined location. It generally requires one correction for repositioning. It's a high conscious control. So an example might be putting a screwdriver into a Phillips head screw. Locating a pencil to begin writing. Putting it on a piece of paper in a specific spot. Typing something on the keyboard. Then you have the P5, which requires multiple feedback. The object is placed in a defined location. It requires multiple corrections for repositioning. and it's high conscious control activity. So placing a nut on a bolt is a good example of that. Putting a staple, or I'm sorry, a paper clip into the corner of the paper is a good example of that. Putting supplies into a determined location is a good example of that. And from there you would move into your auxiliary classes. These are activities that are not performed with the finger or the hand or the shoulder or the trunk, as we stated. This class includes walking, bending, inspection, deciding, and that list really goes on. If somebody wants to know more and more about it, you're welcome to get a hold of me, and I can go through each one of these elements with you, each one of these auxiliary classes. There are several of them, and it's not really something that's worth going through right now. But a couple examples might be, as I stated before, eye control. Counting is an auxiliary. Talking, those are some more examples of it. So auxiliary class examples are extra force, visible hesitation. The value may be used more than one time. The load factor is used. Sustained pressure is needed. Pushing a tack into a board. Or juggling. It's not actually juggling as we see it. It's actually just taking something from one hand and moving it to another. F3, a foot action. Maybe you're pushing down the foot of a sewing machine, or releasing a chair. Then there's walking, of course. Then there's U2, use for one revolution. Intermediate moves that do not terminate or get put. They're usually associated with a tool, less times awarded due to the rapid back and forth movement. So hammering something, brushing debris away from something, that's a U2. So we talked about today was Modapts being widely accepted. Talked about that it's easy to learn, it's easy to apply. Talked to reliability and the consistency of it, and it is accepted around the world, to included by most labor unions. And it can be used in nearly any industry. There's very few industries that it can't be used in. One that does come to my head that's very difficult to use a Modapts study in might be construction. However, there are forms of time studies that can be utilized in construction, such as time sampling. If that's something somebody's interested in, we could talk about that offline also. Here's a way to get a hold of me if anybody would like to. My email address is right down the bottom here. It's btoit@pmcorp.com. Thank you, everybody. Have a great day.